Today we're going to be talking about section 2.2, which is on finding slopes and rates of change. And our goal for today is going to be to find the slopes of lines and rates of change. When we talk about rates of change, that's really going to be the slope in a real life situation. So when we look at the slope, we use the letter M to represent the slope. And that's the ratio of the vertical change, which we call the rise, to the horizontal change, which we call the run. So when we look at the slope, it is the rise over the run. Now this is something, if you don't have it memorized yet, which you probably should because we've talked about slopes numerous times before in Algebra 1, even in geometry, they should go on your note card. So if you look here, we have two different ways of finding it. If we have the graph, we're going to use the rise over the run. How much you go up or how much you go down over how much you go to the right. So that's the rise over the run. If we have ordered pairs, we're going to look at this first one. So you subtract the two y's, and that goes in your numerator. You subtract the two x's, that goes in your denominator. So in example 1, we're going to find the slope in real life. So here it says the roof of an entryway to an office building has a rise of 40 feet and a run of 100 feet. Remember, it's the rise over the run. And so it says it has a rise of 40 feet. That means it goes up 40 feet and a run of 100 feet. So we reduce this. And when we do that, we get a slope of, well, take out a 10, we get 4/10. Simplify it further. Take out a 2, we get 2/5. So it has a slope of 2/5. Or you could even say 0.4. Now, most of the time, especially if we're graphing these, we're going to want to leave them in fraction form because then it's going to be the easiest for us to use that slope to graph our equations. Then if we go to example 2 is a standardized test practice. It says, what is the slope of the line passing through the points -4, -5, and 6, -2? Well, remember, we said that m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So we have to decide which one we want to call point 1 and which one we want to call point 2. And so we'll just go in order here. And it doesn't matter. You can do it either way. So you can call the first one point 1, the second one point 1. You're going to get the same answer either way. So now, what this really tells us is we're going to take the y value of the second point. Well, that's -2. We're going to subtract the y value of the first point. Well, that's -5. Over the x value of the second point, which is 6, minus the x value of the first point, which is -4. And now we simplify. Well, -2 plus 5 is going to be 3. 6 plus 4 is going to be 10. So it is 3/10. And our slope is A. So what I would like you to do now is we're going to do the guided practice questions 1 and 2. And if you turn to page 83, actually 1 through 6. So turn to page 83 in your book. That's where those problems are at. So go ahead and do those. And then you can pause the video. Whenever you are ready to move on, you can go ahead and hit play. And here are the answers to the guided practice questions 1 through 6. Notice on questions 3, 4, 5, and 6, some of them I use the first one is 0.1, and some of them I use the second one as 0.1. Just kind of depended how they looked. And as you do those, you'll figure out which way you want to use it. Now, if you always want to use the first one as 0.1 and the second one as 0.2, you'll always get the right answer. Just maybe more sign changes. So next, we're going to talk about classifying lines by their slope. Now, if we have a positive slope, that just means the graph, if you graph it, it's going to go up to the right. Negative slope goes down to the right. Zero slope means it is a horizontal line, and an undefined slope means it is a vertical line. So in example 3, it says classify lines using slope. Without graphing, tell whether the line through the given points rises, falls, is horizontal, or is vertical. So what we're going to do again is we're going to find the slope. So we have 6 plus 1 over 1 minus 8, which gives us 7 over negative 7, which is negative 1. Well, it has a negative slope, so this one is going to fall. All right, the next one. We have 1 plus 3 and 7 plus 4. This is going to be 4/11ths, which means it's positive, so it rises. We have 3 minus 1 and negative 5 plus 5, which is 2 over 0. Well, remember, you can never have 0 in the denominator. If you do, that means it doesn't go right to left, so it's a vertical line, and the slope is undefined. Okay, so we are looking here at a vertical line. So here we're going to 2 minus 2, 9 plus 9, so it's 0 over 18. So in this case, the slope is 0. And they're not really asking us for the slope, they just want to know what type of line it is. And so it is horizontal. Now, if they ask us the slope of this one, you have to tell me it's undefined. You cannot leave it as 2 over 0. If they ask you for the slope of this one, you have to say that the slope is 0. You cannot leave it as 0 over 18. You need to know the difference between those two. So go ahead and take a couple minutes to do questions 7 through 10. And then when you're ready, you can go ahead and hit play. And here are the answer to your guided practice questions 7 through 10. Again, notice 8 is 2 over 0, so the slope is undefined, which makes it a vertical line. And number 9 is 0 over something, which is 0, so the slope is 0, which makes it a horizontal line. Next thing we're going to talk about are perpendicular and parallel lines. Well, perpendicular lines are two lines that intersect to form a right angle. And then parallel lines are two lines that do not intersect. So when we look at the slopes of parallel lines and perpendicular lines, we'll start with the parallel lines. If we draw these, parallel lines will never cross, and we will know that they have the same slope, which means the slope of line 1 has to equal the slope of line 2. So if we call this one line 1 and this one line 2, then we're going to have the same slope on both of those. Well, if we look at perpendicular lines, like it says, they're going to cross at a 90-degree angle, which means the slope of line 1 is going to be equal to 1, or the opposite of 1 over the slope of line 2. Okay. So realistically, when we talk about those, one's going to be positive, one's going to be negative, and they're going to be reciprocals. So the slopes are going to be the opposite reciprocals in a perpendicular line. So in the parallel lines, if line 1 has a slope of 3, line 2 has a slope of 3. In the perpendicular lines, if line 1 has a slope of 3, then line 2 must have a slope of negative 1/3. Okay? Because it has to be the opposite reciprocal. Now another way to look at those perpendicular ones is we could say that the slope of line 1 times the slope of line 2 has to equal negative 1. So there's another way to look at it. Either of those you can have. And if you don't remember those, make sure to put them on your note card. All right, so the next thing we're going to talk about is example 4, and that's on classifying parallel and perpendicular lines. So it says tell whether the lines are parallel, perpendicular, or neither. It says line 1 goes through -2, 1 and 0, -5, and line 2 goes through 0, 1 and -3, 10. So we have two lines here. We want to determine, are they parallel, are they perpendicular, or is it neither? So we are going to start with line 1. We're going to find the slope of line 1. And we do that exactly the same as we have been doing all day. So this is going to be 6 over -2, which means it has a slope of -3. So line 1 has a slope of -3. So let's do the same thing for line 2. So that one's going to be line 2. So we're going to go 10 minus 1, -3 minus 0. So we're going to have 9 over -3, which is -3. So line 2 has a slope of -3. 1 is a slope of -3, 2 is a slope of -3. They are the same, which means they are parallel. So the lines are parallel because they have the same slope. Now you're going to need to make sure you know that, because that's exactly how you're going to have to answer the question on your quizzes and your tests. Find the slopes, tell, are they parallel, are they perpendicular, or neither? And then give the reason why. Well, because they have the same slope. So let's look at B. So I'm going to take, so you can read these here. This one is as the first one, so slope of line 1, 3 plus 3, -5 plus 2. So this one has a slope of -2. We're going to do the same thing with the next point. Slope of 2, 11 plus 5, 4 plus 4. So that one is 16 over 8, which is 2. So we know that slope of line 1 is -2. Slope of line 2 is 2. So the question is, are these parallel? Are they the same? Nope. So they're not parallel. Are they opposite reciprocals? No. So they're not perpendicular either. This second one, M2, would have to have a slope of +1/2 to be reciprocal. So the lines are neither parallel or perpendicular because the slopes are not the same and they are not opposite reciprocals. All right, so let's jump down to guided practice questions 11 and 12, and they are on page 85 in your book. So go ahead and attempt those. You can pause the video and hit play when you are ready to move on. And here are the answer to guided practice questions 11 and 12. Notice again we found the slope of line 1, slope of line 2 of both of those, and then we had to decide if the slopes were the same, they're parallel. The slopes were opposite reciprocals, like they are in number 11. and they're going to be perpendicular. And if they're neither of those two, then it's not parallel or perpendicular. All right, the next thing we're going to jump down to is the rate of change, and that's how much one quantity changes on average related to change in another quantity. Now, most of the time when we talk about rate of change, it's going to be how much something changes over time. So if we look at the rate of change, we're looking at page 85 in your book. It's on solving multi-step problems. And here's the problem we're going to look at. It says, we're going to use a diagram which illustrates the growth of a giant sequoia to find an average rate of change in the diameter of the sequoia over time. Then predict the sequoia's diameter in 2065. So in 1965, says it has a diameter of 137 inches. And then in 2005, it has a diameter of 141 inches. So we're going to try to find the average rate of change. So it's going to be how much does this thing change over the time period. So again, you are still going to use the slope. The rate of change is really just the slope of a real life situation. So we started at 141 centimeters, or ended at 141 centimeters. And so we're going to take that minus the 137 where we started, because we know that the rate of change, how much did it change over the time period. And so this is 2005, went back to 1965. So 141 minus 37, or 137 is going to be 4. So we had 4 units of change. And when we look at that time period, that's a time period of 40 years. So if we reduce that, it is 1/10. Now, most of the time when we talk about a real life situation, we're going to want to change it to a decimal. And so when we're looking at this, this means inches are on the top, years are on the bottom. So it means it grew 1 inch every 10 years, which is great to know. But this one then, the slope tells us that it grew 1/10 of an inch per year. So this was the slope, or the rate of change, is 0.1 inch per year. So it changes 0.1 inches every year. So it gets that much bigger. So in section 2.2, we're looking at finding the slopes and the rate of change. Remember, we are using finding slopes whether it's on a graph or if it is 2-ordered pairs. Remember, you're going to subtract the y values on the numerator, subtract the x values in the denominator, and find your slope. Or make sure you always reduce your slope. Positive slopes go up to the right, negative slopes go down to the right. If it is a horizontal line, it's going to have a slope of 0. If it's a vertical line, the slope is going to be undefined. And then we also talked about parallel lines and perpendicular lines. Parallel lines have slopes that are the same. Perpendicular lines have slopes that are opposite reciprocals. So here is your assignment for section 2.2.